after talking about rational functions, we're now going to start talking about something called limits, which is actually the kind of beginning point of calculus. So we first need to learn some notation. So when we write a limit, it looks like LIM for limit, and we read it the limit as x approaches c of f of x. And then that's going to equal whatever L is for my limit. So what does it mean to say the limit as x approaches c, which is usually a number? What it means is that as your x values get really close to a certain c, and this could be either getting close from the left side or the right side, then f of x gets close to L, or a specific y value. So if I look at this little squiggly function I've drawn on the right, as my x values get really close to c, so on my graph as I come from the left or from the right, they're getting really close to a specific y value, which we could just call L. So they're getting really close to L. And if you look on the second graph, it's really the same thing. I just put a hole where that point was, and it doesn't matter, even though there is a hole at that point, my limit from the left and from the right is still going to exist because they are getting really close to that spot L. And there are multiple ways that we can find limits, and we're going to focus on finding limits analytically, which really just means algebraically in this video. So the main thing is that to find a limit algebraically, we're going to replace the value of c for x if it's possible. And we'll talk about what does it mean if it's not possible. So in number 1 it says that find the limit as x approaches 2 of x cubed minus 2x. So let's see what happens if I substitute in 2 for x. So 2 cubed minus 2 times 2. 2 cubed is 8 minus 4. So this limit would be equal to 4. That's it. Number 2, we're going to substitute in 1 for x. So that would be 4 times 1, which also mysteriously equals 4. No, not every answer is going to give me 4. So right now seems pretty straightforward, right? Okay. The next one we have a variable, x approaches a. So when we do that, we're just going to have a cubed plus 4a. Just plug it in, plug it in. Now we start getting a little bit more complicated functions. Basically, when you start seeing fractions, that's where I'm going to have to be a little bit more careful, but I think this one will still be a little straightforward. So we're going to substitute in -1 for x. So -1 squared minus 1 over -1 minus 1. So -1 squared is +1, minus 1, sorry for all the ones in this problem, -1 minus 1. Well, what's 1 minus 1? 0. And -1 minus 1 is -2. So that would give me 0, which is fine. 0 is a number. I can get a limit of 0. That's totally okay. Now we're going to get to the ones that are really where I'm going to have to use some of those skills we learned in our rational functions unit. What happens for number 5 when I substitute in 1? I get 1 squared minus 1 over 1 minus 1. Well, 1 squared is 1 minus 1 over 1 minus 1. Well, what happens? I get 0 over 0. This is something called the indeterminate form. And what we have to do then is we have to do some algebra. So just like when we did graphs in the last lesson, you're going to factor the top and or the bottom and see what cancels. So I have the top factors to x plus 1, x minus 1 over x minus 1, and now I have those factors that cancel, which you'll remember on a graph means I have a hole. So now I have, let's try doing the limit as x approaches 1 of x plus 1. And now I'm going to substitute 1 into that function. So 1 plus 1 would give me 2. So the limit of my original function is going to be 2, but I had to factor and simplify before I could get that because the whole was making it appear 0 over 0. All right, so the next one, I'll kind of spoil the ending. We end up with the same situation. 3 squared plus 2 times 3 minus 15 over 3 squared minus 9 is going to give me 0 over 0. You can just trust me on that one. All right, so once you see that it's going to be 0 over 0, we have to factor and simplify. So we factor the top. That would be x plus 5, x minus 3, over factor the denominator, x plus 3, x minus 3. There pops out my holes. Let's take those out. And now I want to find the limit of that function as x approaches 3. And now I'm going to actually be able to get an answer. So 3 plus 5 over 3 plus 3 is going to give me 8 over 9. 8 over 9. Oh, I can't add. That's what I did wrong. Sorry. Hello. 8 over 6, which reduces to 4 over 3. Forgive me for that. All right. What do we have going on in number 7? We have a square root. Is that going to really change my life? Not so much. Let's try plug it in, plug it in. All right. 16 minus 5 squared. So square root of 16, 5 squared is negative 25. You see a problem? Square root of negative. And we're talking about graphs, so that can't happen. So we would say, with limits, we say that a limit does not exist. If you've seen, what's it called? Mean Girls, the limit does not exist. Okay, that's what we're talking about. Does not exist. So we usually abbreviate that D, N, E. Yes, you can now use that quote, and you have become enlightened as to what it actually means. And this is happening because this graph is really the graph of a square root function, like this. And, or not square root, sorry, semicircle. And the 5 is like way over here, and it's not part of my graph. If you imagine a circle with radius 4, and it's just half of that because it's the square root. So the 5 is way over here, not even on my graph. So that's why it's not working. All right, let's look at the last question, number 8. Let's try substituting in and see what happens. And if you can use your infinite powers and see that it's going to be 0 over 0, you could just go ahead and skip this step. So I'm going to get 2 minus 2 over 1 minus 1, wouldn't you know, is 0 over 0. But I don't know about you, but I don't really know about all that factoring stuff when I have a square root. So this is going to require me to have a different skill